So that's who I am, Mike, and Hackintoshers Views, the name of the presentation. So I was motivated to do this talk because I've done some things with Hackintosh and I thought I'd share them. So that's basically my reason for putting this together. We'll go through some of the basics and then I'll do a little show and tell afterwards, and anytime you have a question, feel free to speak up. So why Hackintosh? I mean, you can download a VM somewhere and run it, and you got to play with the Apple OS X system. You don't need to beat around on a piece of hardware that never was intended to run it. And I thought, well, okay, so there are people out there that have Apple boxes and they have to buy new ones all the time because Apple keeps obsoleting the hardware, and because it's in their business to do that. They generate money when they do that. So the other thing is, it's got an Intel chip on it, and it may not be exactly the same Intel chip that it runs on an Apple, on a PC, but it's an Intel chip. How hard can it be? So some people have figured this out already, and this is not my original work. This is something that's been around for at least 5 years, and a lot of people have done this kind of thing, and why not? If you have a computer, you want to work with Apple, if you're a fan of Apple, or whether or not you are, and you just want to try it out, go ahead. So my motivation was I had some hardware and I had some time, and I just wanted to play with it and see what's going on. I like learning something new, and I like working with operating systems. I've been doing hardware things for many years, and being mostly a software programmer in the last couple of years, I figured, well, let's find out something more, a little bit deeper dive in what the hardware is, and learn something about it. So Hackintosh, kind of a cool name. What does a good Hackintosh do? Well, what's the difference between an Apple PC and a regular PC? The BIOS, some of the hardware, and what does that really mean for the operating system? Well, the operating system reaches out to some hardware that it knows about. It can't have it all encoded in itself, so there's several interfaces we'll talk about. But basically, you have PC BIOSes, and their main intention is to run Windows, because that's the operating system that you'll find on most PCs. I mean, Microsoft has contracts with the BIOS vendors. You put a little bit of this in here you go. Apple doesn't have that contract. They're going to do their own thing, but they still have to have BIOSes, because they talk to probably the same vendors that do the BIOS, but they say, we'll do it a little differently, and we'll do some things that'll validate that. So what does the Hackintosh do? It resets the expectations that Apple has. What does that mean? Well, the Apple operating system wants to look at Apple hardware, so what does the Hackintosh do? It makes the existing hardware look like Apple hardware. So how does it do that? Well, what does it need from the hardware? It needs to know how to configure the hardware. It needs to know how to reset the power. When they shut the lid, put it into hibernate mode, wake it back up again when you open it up. So it's pretty simple stuff, really. It's not that hard. And, because it's Apple, they want to change some of the names of things because they don't want this running on any PC. So that's in fact what's happened is you look at an Apple BIOS, it has some of the features we'll talk about, and they're different than the PCs in some respects, and we'll talk a little bit more about that too. So the constraints that you have about this activity is for resetting the expectations. Once the ACP, there are some ACPI tables. I'm a little bit out of sequence here. I'll get into that a little bit later. But ACPI is, let's take a look at it. ACPI, Advanced Configuration and Power Interface. So that part of the system is a bunch of tables that talk about the configuration and the power interfaces. So when you were providing services to the operating system, the Hackintosh does the same thing, but it changed the name so that the Apple is familiar with the name of the objects that it's looking at. And there are some things that are done incompletely in some of the PC BIOSes, and what the Hackintosh does is it provides the additional methods so that it maybe fixes some of the things that are problematic with the system. So there are some constraints, though. When the ACPI tables are read in and loaded to the operating system, they can't be changed. So what does a Hackintosh do is it sits between that loading interface and it loads another copy of the tables into memory. It can change that copy of the tables. It can change the names. It could add additional components to the tables to look in another table for the similar function that's needed, and that's where they can make changes to the methods that are done. So the original ACPI, the original base of the BIOS ACPI table stays the same except for the name changes, and then additional functions are added as well, so that enhance all the functions that the Apple needs. So there are some bootloaders that can do this. They can rename and substitute the ACPI objects, and to bridge the gaps between what the PC BIOS offers and what the Apple operating system expects. Now there are some additional things as well, because there are some hardware differences that are not in the BIOS that have to be dealt with through external drivers. Fortunately, the Apple operating system allows for kernel extensions. There are third-party extensions that it supports, always has, always will, and these are the places where you add in additional components for hardware that is specific to the system that you have. So a lot of the work that's done in Hackintoshing is really these kernel extensions. Do you have to do the work? Well, I mean, if you buy or use pretty standard hardware, you won't. A lot of people have already compiled these things, so all you need to do is find them, and where do you put them together in the soup that you're making, this soup which is called the Hackintosh. So look a little bit back, a little bit deeper into the BIOS and the APIC. So the BIOS is the basic input-output system, what the BIOS is. So it's the part of the machine that initializes the hardware, that makes it ready for an operating system to be loaded and to take control of it and use it better. So it's a program that initializes the hardware, it finds and loads the operating system, and provides services to the operating system to such time as the operating system can serve itself. It also provides some control to the interrupt structures. Well, the interrupt structures are needed because when there are events, how does the operating system find out what those events are, and then what does it do next? So that's the Advanced Programming Interrupt Controller, and there's two pieces to that these days. One is the local APIC, and the other one is the IO APIC. So why are these things important? You find out later that the processor has the local APIC, and the IO APIC is in the chipsets. Both those things work together. So what that means is that you have, when you're going to have a solution for this merging between what the Apple hardware, what the PC hardware has, what the Apple software expects, is you have to find something that supports the processor and the chipset on the system that you're running. Both those things together, and then that gets you a little bit further down the road. And then back to the advanced configuration and power interface. This is the thing that is exposing to the operating system how the system is configured. It enumerates all the devices and all the power events and all the voltage levels and all the stuff that's specific to that hardware. It's brought up in these tables. Some of these tables are useful, some of them are not. Most of them are based around the differentiated system descriptor table that has most of the things that are enumerated. There are additional tables that we'll talk about later. The SSDT is part of that. So what ACPI is then, it replaces plug and play, if you remember what that might have been, if you remember some PC things, and advanced power management. So that's kind of where that is. Any questions about this? Okay. So you have ACPI, you have the one that's on the PC, and there's a difference between that and what's in an Apple. So there is this software called the bootloader, logically speaking. This is the piece that is really the shim that sits between the BIOS and the boot up and the operating system. So the bootloader can take care of some cleanup stuff. There's a lot of things in PCs that aren't used or needed by Apple, and there's no need to keep those things loaded around. So you can drop those out of memory. And then the important thing that it does is it renames the tables the objects in the tables that are specific to the PC to make it look like what an Apple would like to see. So there are other things that have to happen because some of these BIOSes are really differentiated for Windows systems. They're not differentiated for Apple, so there's gaps that have to be developed. Sometimes they're simple. Some of the device support that you have has to get implemented in device-specific methods that are in the ACPI. Some of it is dealt with in external drivers. So you can go with the ACPI stuff if your hardware is very similar to an Apple chip, but it might be a little bit different model number or different subsystem ID. So if you wanted to get started, what do you need to do? Well, you need to know something about the equipment that you're working with. Let's assume you have found an abandoned computer. And why I call it abandoned, because if you make a mistake with this process, you don't want to be losing anything. So consider it abandoned. You know, it's like, okay, this could blow up. It may go away. I'm going to try it anyway. You know, if you go slowly, you'll probably be okay. But if you get in a hurry, or if you make a mistake, you know, you can fry it. It's possible to fry a computer with the system. I did one once. It turned out to be a system that I really liked having, so it was really bad for me. It had an eSATA port next to other ports I like to work with, and I kind of missed that one. But I fried the CPU on it because I play with the undervoltage stuff. So don't do that. So the thing is, you need to know specifics about the machine that you're going to work on, because you're going to try to fit the ACPI tables and the kernel extensions to that equipment. And more importantly, you try to fit that to an operating system as well. And then, you know, you need to know more about what that hardware is. And then you need to find that more support for that hardware in the community. So that's why you need to know the specifics of the processor, the chipset, the audio, the graphics, and the network controllers. Because, you know, who wants to have a computer that doesn't sync to you? I mean, why, if you don't get the audio right, you know, you need to know what that is. And then the other thing to find out is that a lot of this information is precipitously gathered. In other words, people started getting into it, and they're talking about it on the forums. After a while, they started developing a language or a context for the information, but it's not very well structured. You're going to be doing a lot of research. You're going to be looking at a lot of forums, and you know, some things are conflicting in the information that you're going to see. You're going to wonder, like, what does this mean? So you're going to have to do a lot more research and a little bit of understanding. So you really need to have a lot of patience. This is not, you know, something you could do overnight. You could if you had exactly the same processor and exactly the same chipset as somebody who had already done the work, and they did a superb job describing step by step what you needed to do, and you had the pieces that they had, and you bought the same operating system that they did. Because this isn't something that you're going to, well, however you get the operating system is between you and you. But, you know, you really should buy the operating system because, well, maybe you'll feel better about it, maybe you won't, but I'll just leave that out there. So the other thing is to be inquisitive about doing this process. Like, it's going to be learning, you're learning something new and different. Maybe it won't be exciting for you, and if it's not, well, you know what, you don't need to do it. But it was fun for me, and I really enjoyed it, so be inquisitive. But also be specific in your messaging. When you're going to ask questions, you know, a lot of times you see in the forums, people ask a question, well, it doesn't work. Well, that's great. You know, if you run a support organization, you know that's the worst thing you could hear. That's like, you know, it's a brain fart. You need to have, if you want to get a response for your messages, you need to tell them what processor version you're using, what the steps you took to some degree of correctness, and they can help you with them. And actually, they can help pretty quickly when you do those things. And then be humble about it, right? You know, a lot of this is not stuff that is hard to do. Some of it is, but you know, when you make a win, celebrate it, and just remember that you weren't the only one to do it, and you weren't the first. Maybe you were the first on this particular model, and that's fine too. But if you're humble about it, people will come to you and appreciate you more for it. The most important thing to do is to take good notes, because you're going to be moving things around. You'll be trying a couple things out. You may try a combination of kernel extensions and ACPI tables and configuration. There's a lot of moving parts in the whole thing, and you want to make one small step at a time, and you want to develop a good experiment. So that goes with taking the good notes and doing the background understanding of what the process is. So what do you need to have? Well, unfortunately, you need to have access to an Apple computer or somebody who has one, because what you have to do is you have to create an image, an installer image, and probably put it on a USB drive. So that's best done in an Apple box. You really can't do it with a VM. People recommend not using a VM for that. So you need to have an existing Apple computer or a Hackintosh that has Apple operating system on it that you could put the media onto a USB stick. So you need the USB stick, and then the abandoned computer with an Intel CPU. And then you want to make sure that Intel CPU and that chipset are supported on a particular version of the Apple operating system. The older boxes may or may not be supported on Mojave. My experience has been that the really, really old ones won't. The ones that are about 5 or 6 years old probably could run Mojave on. But Mojave may not be your best bet to install. It's more complicated, it's more restrictive. There's just problems with Mojave. And Catalina, the latest one, a lot more problems. So you may be better off looking at a Mavericks or Yosemite, but that depends. So once you've determined which OS fits your hardware, a number of them will, but start with maybe an older one, and then you pick your operating system. So where do you start when you have all these things you have? You have to identify the processor, the chipset, and the controllers. So how do you do that? Well, there's a couple tools out there. If it runs Windows, from that box you can download a program called CPU ID. It can get you the information about the processor and the chipset, and it might get you some information about the audio ports as well. If you have Linux that you can do a live boot on that, you can download and run FWTS and dump it, and basically what that does is it gathers the information that Linux would have, like the DMI information with DMI decode, the processor information from proc CPU info, the PCI structure from LSPCI, and other things. So it does that all in one fell swoop. And FWTS is a pretty cool tool anyway, because it'll also check the compatibility of your ACPI with the ACPI spec, not with Apple, but the ACPI spec. So you can do things like test does the lid work. You can do sleep state testing if you want to with it as well. Fairly complicated. I don't recommend it. The only reason I'm mentioning it here at this point is so that you can gather some of the information about this processor and chipset and system that you're going to work with. So then you want to find where the operating system that would fit that combination. There's several that fit, so there's some that don't. So when you find the operating system version, then you buy it, and then you look for the installation guide and pour through those, really understand what they are, reread them a couple times, because some of the things we're saying are subtle. Some of these guides are written like you already have done it because the person who wrote the guide already did it, but they didn't understand that maybe you don't quite understand what they're saying, the terminology they're using, maybe specific to their group or to their forum, or the way they just do things. And it may not be something you completely understand. So look at that first, and then the other thing is that for a particular processor or chipset, there may be some issues with it. Support may or may not be great for that combination. Where you're going to find most of the problems really with network controllers, like Ethernet ports. Most of the time, those are pretty well supported. But Wi-Fi cards are terrible. If you have like an Intel chip for a Wi-Fi, component, you're probably not going to be able to use it because the Apple doesn't support it, and nobody's written a kernel driver for the Centrinos. It's unfortunate because it's there in a lot of machines, but that's not going to work out too well. You may have to buy a network card, a network chip, a Wi-Fi chip to make it work. You don't want to do that right off the bat. You want to make sure you got the thing working first, and then once you have it working, then make the investment for the Wi-Fi card. So you look through all the issues that are there, and the issues are often with the installation guide, which over time changes because over time the operating system changes, and all these other kernel extensions and pieces that people had written, those get upgraded, those get improved, and you know, it kind of pushes things out for getting it done. Then you get the operating system. That's probably the easiest thing. How do you get it? Well, if you have an Apple system already that you're about to upgrade, you have a great opportunity to get the operating system if it's the one that you want. When it comes to the upgrade part and you're about ready to start it, stop it. And then look at the installation guides, and then you can run this thing called, I think, create install media, to basically take that installation, instead of putting it on that machine, put it on a USB stick. And then if you want to, you can upgrade that machine, but once you do that, it takes away the pieces that are in place. There's some image files that are there. Once you do the installation on the on the Apple box, it takes away that image so you can't use it again. But anyway, you obtain the operating system through the legal means that Apple provides you.
I have a question.
Oh, yeah, go ahead.
So doing this, you're violating the terms of service, so what is the point of obtaining it through legal means? You're already violating various different agreements that you're making when you install the operating system.
What agreements am I violating?
In the terms of service, it says you're not going to install it on anything but Apple hardware.
Oh, okay. Well, then I'll take that out for the next one then.
So if you're violating something, why?
Oh, that's a good point. That's a good point. I guess I didn't read the agreement. Sorry.
The whole thing?
Huh? The whole thing? Yeah, I didn't read the whole thing. I did not read the whole thing. No, I didn't. Okay, good point. So what problems can arise with this situation? Well, when a vendor builds a PC, they have a limited time to market. So what do they do about the ACPI? Or maybe they implement enough of it that Windows can run. I mean, their contract with Microsoft may say, you need these things in here. But there may be some additional things that could be in there, but Microsoft takes care of it. Apple doesn't. So you need to provide some of the functionality that isn't there to make it work. And that may be true mostly for Dell computers. HPs are better. So, you know, given model, given day, you know, vendors do different things with the ACPI. They don't support it quite as well. And then through all the reading that I've done, there are several places where BIOS bugs pop up, and they're somewhat subtle. So, you know, you may want to, the reason you want to do all the research is to make sure that you have enough information to guide you with the process. You know, you may run into a problem with a particular choice of computer. Your computer may not be worth it if the issue is severe. And, you know, best to stop before you do any purchasing of anything else like additional parts and stuff. So the big things are when you get to a point with your Hackintosh and you've got it working, you're feeling pretty good about it. Okay, let's turn on the CPU power management stuff. You got to be really careful about that, because that's where you can run into situations where the specification for the given hardware that you have are probably not robust. And if you start doing things like pushing the CPU clock up high, you might burn it up. If you put the undervoltage down too low and you put a setting in there like that, you can brick the motherboard. So that means that if you replace the CPU, it's still bricked. So you got to be careful when you play with the CPU power management stuff.
Also, one thing I've run into time or two before is you can have two computers that are the same. That the motherboards from the same manufacturer, but the daughter boards are different because it's according to what was available on the market at the time that particular machine was made.
Yeah, that's why I need to know what all the components are. The controllers, the the north bridge, the south bridge, the chipset, and the CPU. And sometimes you'll see in installation guys, they'll say, well, this is for a Dell model 6230. Oh, great, I got that model. Well, it's for an i7 chip, and I got an i5 chip. Do I proceed with this? Certainly don't want to do the CPU stuff. There are some things you want to stay away from. Like they're called CPU friendly. And that's one you definitely don't want to be using when you're first exploring. So there are, like you say, subtle differences between the model numbers and the ones that were installed. So the install guides may have really good definition which chipsets are they make for, and some of them don't. They may have a really good processor definition. Sometimes we'll just go with, is it a Haswell or is it a Broadwell? A general genre of chips, processor type. And maybe that's good enough. Most of the later versions of the kernel extensions are probably okay. And in that case, then your issues are really, do I get the ACPI tables right? And then there's other things too. When you get to the later versions of the operating systems, the Apple operating systems, they turn on system integrity protection, which is their way of basically neutering the root privilege. The system that you would have to touch, the portion of the system that you have to touch to install these kernel extensions are considered read-only. And the only way you can turn them off is running a program that has to be run during the recovery mode. So you have to make sure you have a recovery mode installed. And that's where you get into creating the media, doing it the right way to do it. The right way to do it is to use the Apple tool to build the media, because it puts the installer image on the USB, and it puts a recovery partition on the USB as well. So you would run from the recovery partition, do things like reset the password of your box or turn off the system integrity protection. So that you probably would like to do that at some point, or if you're not feeling comfortable with it, load an older version, start with an older version of the operating system. So then, continuing down the path of doing this, you want to design controlled experiments. You want to match the boot and the install programs to the vintage of your computer. It's not a big deal, but if you have a really old box, you probably want to use something like Enoch or Chameleon. If you have a newer one, Clover is your best bet. Clover is the best supported these days. Most of the new kernel extensions, the tools that do the configuration changes, they all support Clover. And a lot of the, several of the forums won't answer any questions about the other ones. So, but I'll just put it out there that there's older versions that are available. And then you learn how to ask for help and who to ask. There's times that there's a forum called Tony Mac x86, and that their big thing is the Unibeast, multi-beast method of installing. Basically, you install and they're really anal about how they get the operating system to the box. You have to basically download it from your Apple ID from the Apple Store. Well, all right, there's other ways of getting the Apple operating system, and I choose not to use that method. So I haven't really touched it, but Unibeast is one way to install the operating system to the box. And then multi-beast is the post-installation part that does all the kernel adjustments and all the things that make it work great. So if you go over to Insanely Mac and you ask somebody a question about a Unibeast multi-beast install, and say, no, we don't talk about that here. And here's why. They have a page that they'll refer you to, and it goes to great length that tells you nothing about what happened. But apparently the people that run Tony Mac did some things that upset the people in other parts of the community. So there's, that's where you have to learn who to ask. So if you go with Insanely Mac, they're pretty generic otherwise. I've had good success looking at OS X Latitude. We'll talk about that in a bit. So when you're making it work, get the graphics and the keyboard and mouse thing working first. That's your best bet. You don't have to have the cues and such, but you get the basics going. And don't rush installing kernel extensions. Those are the things that are for the drivers for the hardware that you don't that Apple doesn't know about, your non-Apple friendly hardware stuff, like your Wi-Fi chip. Just get it working first, get a feel for what the configuration stuff is, and always do this in small steps. Take good notes and back up the configuration and whatever you're working with. So basically you can install with the USB stick and then boot from the USB stick, changing the configuration on the stick until you like it. And then once you do that, then you can copy the portion of the installation over to the system, and they just start booting from the system with that. And then, after all that, a redress back to Clover. So it'll make it look like an operating system. It'll make it look like a particular version of the system. You can find that out. There are places you can go to find out what models of Mac were supporting the particular processor or a like-kind processor that you use. And you might want to pick one or two of those, different ages. It really doesn't make a lot of sense to me. I mean, some of these names that they have are, well, maybe it's an iMac one time or a MacBook Air Pro or a MacBook Air, right? So, well, what's the difference? There isn't a whole lot, except if you know that the operating system takes advantage of some of the acceleration in the other models, it might make sense to pick one of those. So it comes right down to it. You get to the USB stick, there's two ways to go. You can use the old style master boot record, where you have a portion of the actual system BIOS works with the master boot record. You load up a boot code, it'll find the sector on the USB stick or where you're going to boot next and run up. Or you can use the EFI system partition, the EFI partition, where you have portions of boot load on it for different operating systems. So you have more flexibility with the EFI, but you may have a problem with the BIOS of your machine that it doesn't support it. So if you have a really old machine, like say a Dell 6320, you probably have to use the MBR method to boot, because although that particular system has EFI, it's really not that well supported. I've had a lot of trouble with it, and I'm really not doing anything with that right now because I've got other machines to play with. But so EFI is kind of like the way to go. So these are some references for ACPI discovery. If you get to the point where you feel like you want to do more with this thing, you've got the system basically running, and now you're going to look at building your own DSTT changes, or you're going to do more of that work with a dynamic DSTT. The more that you can do with the configuration ahead of when the operating system loads, the more flexibility you have when that operating system changes. It will, when they go from version, say Sierra to High Sierra, there's a significant change in how they structure things. If you go to Mojave, they change the file partitions on the disk. So things that you could do with the recovery portion of your USB stick on High Sierra, you can't do with Mojave, because it uses the APFS file system. Completely different, it's encrypted and all that stuff, so very different. So these are some places that you could look for some general information. You notice they're Linux based. This is just because I was lazy and I didn't have a lot of time to make this presentation. There's better places to look, but once you get into it, you'll find more about it. So join the forums, look around at the install guides, look at some things that are on GitHub, and then go back to the forums and start from the end of the really long threads that look interesting to you, because that's probably where the current work in progress is. It's very unstructured. The forums are terrible to search, in my opinion. I've not found a good way to search them. And if you find a good way, tell me. I'd be happy to know. I'm going to try to reboot the box and see where we go with this. Show what seeing the Dell logo in the startup of the EFI boot. I was trying to find the different partitions. I got 3 or 4 of them loaded on here. You don't see what I'm looking at right now, but basically it's a little window of things. The Clover allows you to select other partitions too. I have this triple booted. I have Windows, Linux, 2 Apples running on it, and yeah. So. Yeah, it took a little while to do it because Windows isn't that easy to play with. There you go. It says Dell on the box. Yeah. So it's, just another operating system. No big deal. The thing that's really kind of cool about this is I didn't have to write a driver for this USB-C Thunderbolt. It just worked. I have an inland. I don't have the Dell USB-C, and that worked too with the Apple OS. So I think that's pretty cool. So that was Sierra. I'm gonna load up Mojave. Once you look at it, it's like, okay, it's Apple, so what, right? It's a so what thing. I did it, so what?
You done Catalina yet?
Huh?
Catalina?
Not on this machine, but on Inspiring I did, yeah. Actually, when you, if you have like a desktop computer, you're gonna find that a desktop is gonna be easier to work with. And the reason for that is the BIOS doesn't have as much power management stuff on it. You had no lid to worry about. You really don't have to worry about hibernating a desktop. So there's a lot less crap, kernel extensions that you have to deal with. So now this one, I'm showing the Mojave on here, but it's not coming through on the USB. Well, sorry about that. Oh well. Kind of cool showing the night picture now. It was showing the daylight picture during the day. And Catalina is kind of fun too. When you see Catalina running, it has you see the sun, different light shining on the island of Catalina, which is out off of Los Angeles. But it's local time zone. It's not the time zone where it's out actually there where it's showing. So it's slightly misleading. Are there any questions? Thoughts, concerns, comments? Yeah.
What's the update process like? So security updates come out often for iOS or Mac?
Yeah, they do.
How do you update?
Oh, well, you just let them update.
Oh, okay.
Yeah, there's nothing special about it. If you do the Hackintosh, where you keep most of the changes in the ACPI tables, and you don't do too much with kernel extensions. Anytime you do something with a kernel extension, it's going to be reloaded because it's going to be a new operating system. It's going to be new portions of it. So that's going to change things. But if you can keep most of the changes in the ACPI tables and let Clover do that, there won't be any problem at all. Yeah. In fact, when you install Mojave, it'll reboot a couple of times, and Clover's smart enough to know the last boot. He's smart enough to know that there's a preloader that has to be run, so that it figures all that stuff out. Yeah.
So what about the TPM chips? Every Intel Mac has got TPM chip with a certificate in it.
I really haven't done anything with the TPM chips. You can do stuff with file crypt, but you have to be careful with the keying, as you would in any situation. I've not worked that area. I haven't really seen a lot of discussion on that, but there are some places in the forum we can find out more about that. There is some support for TPM chips. I don't know if there's anything for T2 chips on non-Apple hardware. I don't think there is. I think it's an Apple-only situation, right? So, okay.
I thought when you were installing, I thought it checked for the TPM chip and Apple hardware to protect.
That's turned off. It doesn't force it. Yeah.
Do you have full hardware compatibility on that laptop? Or is
This
there anything
one,
missing?
no, because it came with an older version of the Broadcom chip. And the Broadcom chip, it's really interesting. The Broadcom chip, there's an extensive, the DW1820A is the one that this one has. There are like 3 different serial numbers on, subsystem numbers on it, and there's 3 different ways that it's supported. I have the one that's not well supported, so I don't have full capability. So, but the USB-C port works great, and I have network connectivity when I have like a RJ45 cable on it. Or maybe I can make it work with a USB external Wi-Fi if I wanted to.
What about the applications that interface with the Magic Touch Bar? How is that replicated in software anyway, or like for instance from like Photoshop?
I haven't run that to know for sure. Touch Bar, there's been some discussion about that I've read. I don't really know, but I think it's at least partially supported. Yeah. The way to find out is to look and see, does anybody have any trouble with it? Some people have trouble with working, and it depends on the hardware, right? Some people have made it to work for some of those applications.
What model of Dell?
This one is an XPS 9350. I wouldn't use it as a first choice, just because it's it's got a dinky keyboard on it. The form factor is nice, and I kind of like it. But I really like my 6230 better. I like the full size, the touch and feel of the full size keyboard. This is kind of chiclety, and so I don't really like it that much. It's a personal thing, right? So, but there's all kinds. I mean, if you go to Insanely Mac and take a look around, look at the install guides on. They have Acers, they have Lenovo's, they have HPs. So does OS X Latitude. It's not just Dell Latitudes that they support. And it's not that they support them, right? The installation guys have said, you're on your own. They said right there in big red letters, you could fry your computer. Don't blame me. It's like it's that's why you have to be careful. You have to know the CPU, the chipset that you're working with. If you grab somebody's bag of Clover installation with all the kernel extensions, you may be getting their problem too. So you want to be careful what are the kernel extensions that you're putting on your Clover partition. Because that could, like the CPU friendly stuff is on there, but it's for a processor that's not your processor. Bad things could happen. But I've had a lot of fun. I've done maybe 5 or 6. You come on up now, Stuart, if you want.